Swayam Prabha. Digital India. Educated India.
Welcome to my course on Introduction to Abrasive Machining and Finishing Process. Myself, Dr. Mamila Ravishankar. I am Assistant Professor in Department of Mechanical Engineering at IIT Guwahati. Okay. So, the first and foremost thing that I am going to deal with is what I am going to talk about in this particular course, and in a summary way as well as in the elaborative way, so that you can choose whether you want to take this course or not, or why this course is important, other things. Coming to the overview of the class, in particularly what I am going to talk, just I acknowledge those people who are helping from the background or who are helping technically, non-technically and all those things, and why and who can study this course. So, reference materials which are also a part of this course, so that you can refer to the books and papers relevant to this particular course. Introduction to manufacturing, because abrasive machining and finishing process comes under the category of manufacturing. So, just a glimpse why manufacturing is important and other things I will study, other things I will explain. Overview of the syllabus in a normal way, what are the overview, content and all those things, and I am also going to talk about in a elaborative way the same things. So, introduction to abrasive particles. Before you are going to study about this particular course, what is an abrasive particle, how can you measure the size, what are the varieties, what about the cutting edges, what are the rake angles and all those things. The manufacturing of abrasive particles, how these abrasive particles are fabricated, and the size and shape of abrasive particle, how do you determine the size of the abrasive particle, and I conclude this particular class with a summary of the class, what I am going to talk in this particular class. So, the acknowledgement goes, I am very thankful for Professor Kijwania. He is the head center for education technology and who gave me this opportunity to explain this particular course or disseminate my knowledge about this particular course on introduction of abrasive machining and finishing process. He is the person who is controlling all these things. Okay. I am very thankful for the staff who tirelessly working for the editing, taking the video and pre-processing, post-processing and other things, who are there at the Center for Education Technology, head of the Department of Mechanical Engineering where I belongs to, Professor Divedi ji, and thanks to the MOOCs and IIT Guwahati in broad spectrum. Okay. Thank you for those who are helping hands for me in this particular course, my TAs, Jayant Reddy, Abhishek Gupta, Mandeep Saini and Rawat, these are the people. Apart from all these people, I would like to acknowledge one person who helped me technically. He is Narayan Reddy. He is no more. So, he is very good friend of me. He helped me in many ways. So, technically he helped me a lot. Coming to the course, on overview of my course on Introduction to Abrasive Machining and Finishing Process. Who can study this course? So, normally this is particularly very helpful for mechanical engineers, production engineering people, aerospace, material science and metallurgy people, and moreover it can also helpful for other departments who want to learn about manufacturing and all those things. In the intended audience, it can be useful for the BTech students where you can learn the basics, MTech and PhD students you can learn the basic as well as you can take up some of the course contents as your research topics, faculty who teaches manufacturing in particularly about the machining processes. So, as you know, this particular course comes under the subtractive manufacturing. So, number of hours is 20 hours course. So, I am going to take this particular course in 20 hours. List of the reference books. So, the first and foremost book that you can refer is Principles of Abrasive Processes by M.C. Shah. So, Professor V.K. Jain, micro manufacturing process, because advanced abrasive finishing processes you can take from this particular course. And elaboratively, if you want to understand the mechanics, if you want to understand the what is in-depth knowledge and all those things, if you want, you can go for nano finishing science and technology, where you can study analytically and all those things. As this course is an introductory course, you will only understand how this process works, and I will give you the glimpse of overview. I am not touching the mechanics and other things. So, I am not going to teach you any mathematics or something. I will touch some of the mathematics, not in deep mathematics. In case if you want to understand, so you can see this particular book like Nano Finishing Science and Technology by Professor V.K. Jain, and Joseph McGough is another book where you can study about the advanced methods in machining. Professor G.K. Lal book I am following for the grinding operation and conventional machining and finishing operations, and Professor Ghosh and Professor Malik's book in manufacturing science, which gives you overview of abrasive machining and some of the finishing process also, and Astakov. So, I am also teach in this particular course about grinding fluids and ecological aspects of grinding fluids and all those things. It also called as a cutting fluids, but same thing holds good for the single point cutting tool and multi point cutting tool. Cutting fluids are same. So, we can use those cutting fluids as a metalworking fluids in this particular course. Okay. Not only this course content is from this particular textbooks only, I have taken some of the research papers, latest research papers, and I have compiled in this one. So, it content is not only the part of this particular books, you can also refer to the latest papers in this particular area. Okay. Coming to this introduction of this particular course, which is a part of manufacturing, that is why I am going to talk about a little bit about the manufacturing. What is manufacturing? Okay. Successful creation of men's material welfare depends mainly on the ability of natural resources and extension of human efforts both physically and mentally, and development use of power tools and machine tools. Okay. So, in a broad view, manufacturing is nothing but conversion of raw materials using certain energy to a finished product. Assume that I have an bauxite material, I want to make it a aluminum sheet for a car, I have to use certain external energy, and then I have to prepare a final product. This particular process of conversion of raw materials into the final product is nothing but the manufacturing. Importance of manufacturing, just you can see for the auspiciousness of this particular course, I just gave you a glimpse. This is a temple where they have fabricated using subtractive manufacturing process like machining, finishing and other things. Okay. Importance of manufacturing, I said we have the machining as well as finishing. So, I have a raw material that converting using machining and other processes, not only machining, here there are other processes. So, you can fabricate a car structure and all those things. Another one, finishing applications, if you see the gold ore, from that ornaments, you can gold ornaments and all those. This is the importance of the manufacturing, and the manufacturing, if the country's manufacturing is most developed, that means that that country can become one of the superpowers. For example, China's manufacturing is so good, and we should aim as an Indians, we should also equally good compared to China, so that we can also become superpower. So that means that I request all the people that manufacturing is one of the good courses which can make India a good country. So, most of the manufacturing industries are there in India. So, you gain the knowledge and you work for those manufacturing companies and make India great. Okay. Coming to the syllabus of this course on Introduction to Abrasive Machining and Finishing Processes, the overview of the syllabus. Chapter 1 deals with Introduction to Abrasive Particles, classification of abrasive processes and other things. Second one, I am dividing a particular chapter into 3 classes. I am mentioning 3 classes, it may sometimes go beyond 3 classes or it may end in 2 classes itself. Okay. So, for the particular plan is concerned, I am having the 3 divisions. The first division is chapter 1A, Introduction to Abrasive Particles and Classification Abrasive Processes. Second one is grinding process and its classifications, applications, grinding fluids and other things. The third one, you will see the grinding process, tribological aspects, grinding fluids and sustainable grinding and other things. Then comes to the conventional abrasive finishing processes like honing process, wire brushing process, lapping process, buffing, super finishing and other things. We also study about what is surface integrity. The surface integrity refers to surface metallurgy plus surface morphology and many other practical conventional finishing processes we will study in this particular chapter 2. In chapter 3, we study advanced abrasive machining processes. So, I am talking about machining as well as finishing. Sometimes I am talking about machining, sometimes I am talking about finishing. So, you will understand what is the difference in the later slides. So, in the chapter 3, advanced abrasive machining processes, we study about the abrasive jet machining, abrasive water jet machining, ultrasonic machining, followed by elastic emission machining. In the chapter 4, we study about hybrid advanced abrasive machining processes such as electric discharge grinding, electric discharge diamond grinding, electrochemical grinding and chemomechanical polishing. These are the hybrid advanced abrasive machining process we will study. Then we go ahead with the latest trends in the abrasive finishing processes such as polymer assisted abrasive finishing process, where we study about abrasive flow finishing process, advances in abrasive flow finishing process and applications and allied processes of abrasive flow finishing process. Some of the papers, whenever you go through, it is also mentioned as abrasive flow machining process also, because in olden days people were using for abrasive flow machining applications like abrasive flow deburring process and other things. Nowadays people are using for finishing, that is why this is named as abrasive flow finishing process. Then we will go for magnetic field assisted abrasive machining processes and finishing processes, that is called magnetic abrasive finishing, vibration assisted magnetic abrasive finishing, chemomechanical magnetic abrasive finishing, magnetic abrasive deburring, magnetic jet polishing and other things. Okay. Here it is written machining and you can correct it as a finishing. In the chapter 7, we go for magnetorheological abrasive finishing processes. In the previous case, normally you will have the particles, here you will have a magnetic slurry. So, you go through the magnetorheological abrasive flow finishing process, magnetorheological finishing process, magnetorheological float polishing and other magnetorheological or magnetic abrasive finishing processes you will go through in chapter 7. In the chapter 8, you will go with hybrid abrasive machining processes or hybrid abrasive finishing processes. Chemomechanical magnetorheological finishing process, finishing of advanced materials like biomaterials, like implant materials finishing and other things, and latest updates in abrasive finishing processes. Abrasive finishing processes that are there in the latest trends from the research papers I will explain to you. Coming to the classification of manufacturing processes, there are machining process, forming process, joining process, casting process, powder metallurgy, sheet metal processing and finishing processes. Among these, so machining and finishing processes are the ones that comes under the abrasive processes. Okay. Normally abrasives are used for machining as well as finishing, which are nothing but the subtractive manufacturing processes. Introduction to machining and finishing, we will study about importance of machining and finishing, basic approaches in manufacturing, what are the difference between machining and finishing, and importance of machining and finishing, why machining is important, why finishing is important, what is the conventional and advanced finishing processes towards a sustainable and all those things. This point 4 we come across in the later cases, but 1, 2, 3 we will come across now, and study of the surface integrity, about surface morphology and metallurgy will come in few classes later. Okay. first and foremost, why you have to study this particular course? Okay. So, that is a basic question that you will always have. Okay. So, this is a before and after. You can see the surface here. Okay. The welding is done, but you cannot directly use it because the surface morphology is different, at the same time surface metallurgy is different. In order to sell your product into the market, you need good aesthetic appeal, you need perfect tolerances and other things. For that purpose, you should go for machining and finishing of this particular things, and you can clearly see here how the things are achieved. This is the beauty about abrasive machining and finishing processes. If at all you want to go for advanced finishing of implants, okay, if at all you can see the knee surgery or total knee replacement, other things, if you see, you need to go for the finishing of knee implant. This is the casted product, and this is the finished product. Okay. Assume that you are going to keep the casted product directly inside the knee. What will happen? The surface roughness is very high, metallurgical aspects are different. So, there will be a corrosion effect, there will be a friction. So, lot of problems will come. For that, to overcome that, you need to go for abrasive based machining and finishing processes. In the case 1, that is the pipe and welding and machining, you can go for the abrasive based grinding processes, but you cannot go for a knee implant. So, you have to go for abrasive finishing processes. So, in the case 1, you need abrasive machining processes. In the case 2, you need to go for advanced abrasive finishing processes. Okay. What are the two approaches in manufacturing? Normally, there are top down approach. Top down approach means I have a material and I have to do the machining and take out the useful product, that is called object that I want. This is called top down approach. I have a shape, big shape, out of which I want to make a small component. Then I am doing a machining process. I am doing a machining process to make a component, that is called top down approach. I am coming from top to the bottom. Okay. In the bottom up approach, normally I have a powders and I am making a component. Like powder metallurgy is a bottom up approach. I have a powders, I am going to compact it, sinter it, and I make a component. In a first case, I do the machining operation. Okay. So, there is some problem in the top down approach, such as material waste will be there in terms of chips and all those things, and this particular course is followed top down approach. And mostly people who are sitting, maybe a BTech student or starting of MTech students and other students, you may not know what is the difference between a machining and a finishing. Okay. Many of you may know. Okay. So, you should understand machining and finishing, because this particular course is abrasive machining as well as finishing. So, abrasives are constant and you are using for machining applications as well as finishing applications. So, you should know what is a machining and what is a finishing. In a machining process, if you see how much material I am removing from particularly this component is important. That is my major criteria. In a finishing process, my major criteria is not about how much material I am removing. Whether I got the particularly required surface finish or not. That is the most. Even though I remove less material, if I am getting a surface finish in a good way, that means the surface roughness in a very low value, that means that is my finishing process. Okay. So, you think about what the surface roughness that I want, so that I can sell this particular product in the market. That if that is the criteria, then you have to go for finishing process. If your criteria is machining, so you just go for the material removal criteria. Okay. Assume that in a 10 minutes time I want to remove 10 mm thickness. So, you have to go for machining process. So, when the material removal takes place, normally if you see the abrasive machining process, which is a top down approach, in a grinding process or in a lathe process and other processes, normally the machining takes place after the yielding point. That means that is why these machining processes are called as severe plastic deformation processes. Okay. So, once after this one only the material start shearing from the workpiece. Okay. So, we do not bother about much about the elastic limit and the other things, we directly go for failure. In this particular slide it is failure, but the thing for a machining people and a finishing people, you need to remove the chip. That means that you have to delaminate or you have to dislodge that particular chip from the surface. That means that you are fracturing or you are shearing. That means that this particular thing will start after this point F. Okay. So, do not think in a negative way that we are fracturing the particular component or not. It is not the fracturing, we are taking out the chip from the workpiece. What I am going to teach in this particular course, like introduction to machining and finishing process, you have seen summary, but in a elaborative way how I am going to teach this particular course. This particular thing will help you whether you are really liking the course or whether really it will help you in your future or really you are going to gain the knowledge or something, that you can decide by seeing this elaborative way of this particular course. In the course 1, I have already taught you what you are going to study, that is introduction to abrasive particles, bonded, unbonded, super abrasives. When you call it as a super abrasive, when you call it as a bonded abrasive, when you call it as an unbonded abrasive and other things you will study about this one. Then you go about conventional abrasive finishing processes and grinding other things. Among what is grinding and other conventional finishing processes, but you may not know what is the difference between bonded abrasive and unbonded abrasive. This is called unbonded abrasives. And this is called bonded. Okay. Whatever the abrasive particles individually you see in a market, or if you want to purchase, if it is individual particles, that means called it is unbonded. Whenever you see a grinding wheel where vitrified bond, rubber bond, shellac bond is bonded, that means that if you see a abrasive particle in a grinding wheel, that is called a bonded abrasive particle. Okay. So, this is the surface of a grinding wheel, the last figure is the surface of a grinding wheel, but if you see unbonded, these are the individual particles, it is an individual particle. So, chapter 1 also deals with grinding process. So, we study about the grinding wheel specification, classification of grinding processes. What is the surface integrity? That means that how do you divide into two things, that is surface metallurgy and surface morphology. Okay. Grinding fluids, which is a important one, because this is an important whenever you go as an engineer to a certain company, people are using cutting fluids or the grinding fluids, how this cutting fluid fall in the machining region or the grinding region, how it will emit the emissions, how it is going to affect the particular operator and surrounding environment and other things. By studying about the grinding fluid emissions and its consequences, how to resolve this particular problem. So, sustainable grinding, and you also study about the micro grinding process, when you call it as a micro grinding, when you call it as a macro grinding, and applications of various grinding processes you will study. So, you can see here this is called a surface grinder, and how material is removed you can see in this particular picture. Okay. This is how the material is removed from the surface grinding process. The conventional abrasive finishing processes, you will study about the belt grinding process, honing process, wire brushing process. You will also study about the lapping process. Normally lapping process follows the 3-body abrasion, the grinding process will follow the 2-body abrasion, and these are all things you will study in the tribological aspects of grinding. You will also study about latest things like pitch polishing, what is pitch polishing and other things, and you study about the sand blasting, micro blasting and vibratory finishing, drag finishing. These are the common conventional finishing processes where mass production or batch production is used. Coming to the advanced abrasive machining processes, as you know, you are going to study about abrasive jet machining, where abrasives are getting assistance from a compressed air, because the air is a carrier medium here and abrasive particles will follow the path of injecting the air, but the air has a drawback, that is it can diverge easily, because of which the dimension that I want to get may be disrupted. For that purpose, people have gone for advanced version, that is called abrasive water jet machining, where you will get a highly compressed or pressurized water jet mixed with abrasive particles will go. Here, compared to abrasive jet machining, you are going to get better and narrow precise structure or whatever you want. Compared to abrasive jet machining, here the divergence is slightly less. And you will also study about ultrasonic machining, where piezoelectric transducer will give ultrasonic vibrations, and you will have a abrasive slurry which is passed from slurry nozzle, where you will have abrasive particles, and this particular thing will reciprocate and you will get a whatever the shape is there, converse shape you will generate. We will also study about elastic emission machining, which is one of the latest trends of machining, and you can also call it as a finishing operation, because you can remove the material in a very minute amount. We will in the chapter 4 we study about advanced abrasive machining processes which are hybrid. Normally hybrid means you are clubbing one conventional machining process, that is grinding process, you are mixing with some of the advanced machining process like EDM, electrical discharge machining, then these both are clubbed, then it is called hybrid. So, one of the common process is electric discharge grinding, where electric discharge machining and grinding process are clubbed each other. That is why this is called electric discharge grinding. So, in a electric discharge grinding, you will have a discharge and you will have a machining with abrasive particle. Okay. So, discharge, normally if at all I want to grind the ceramic particles like silicon carbide or alumina or bioceramics like hydroxyapatite, bioglass and all those things, what you cannot do with a slightly higher abrasive particles. For that purpose, you have to go for electrical discharge grinding process, where your discharge will help to make this particular process soften. This particular thing will become soft and your abrasive particle will remove it. That is the beauty about this particular process. Similarly, electric discharge diamond grinding, where you are going to use diamond as abrasive particle, and there is another technology called wire EDG, that is called, instead you hear the people are clubbing the grinding with wire EDM, and you can have a wire EDG process. Another process is electrochemical grinding, similar technology, where you club electrochemical machining with grinding process, and chemomechanical polishing, or some of the papers also call it as chemomechanical planarization. Okay. So, whatever you are seeing here is wire EDG, and whatever you are seeing here is EDG or electric discharge diamond grinding. If the abrasive particle is silicon carbide or alumina, it is called EDG. If the abrasive particle is diamond, then it is called as electric discharge diamond grinding. Then comes to the chapter 5, where you are going to study about polymer assisted abrasive finishing process, which is a good process for complex surface finishing and other things. There are 3 varieties. One is one-way abrasive process, and two-way abrasive process, and orbital. Okay. So, in one-way process, you are just injecting the, here the medium is most important. In this particular chapter, you study about the machining, as such the machine structure, medium, tooling, other things. In one way, you are just pushing the medium, that is polymer plus abrasives plus rheological additives. You are pushing in this direction, and your component is here, and you are finishing, and again it is coming here. In a two-way, your component is here, this is the component, and you are reciprocating from two directions. This direction it is goes, whenever it is upward direction, this also goes up, whenever this goes down, this also goes down. Okay. So, this is called a two-way. And orbital, you will have a orbital motion where if at all I want to finish the complex blind holes, other things you can do by orbital finishing, but here also medium is reciprocated. So, medium will come, again this piston will move up. So, normally on an average if you club these motions, you will have a this particular motion. Similarly, in the two-way also you will have a this particular motion. It goes up and comes down, goes up and comes down in a two-way. Similarly, in the orbital also. Magnetic field, which is another field of interest to many of the masters and PhD students, along with the polymer rheology. You can also study about magnetological fluids. Here magnetic abrasive finishing, vibration assisted MAF, and chemomechanical magnetic abrasive finishing, magnetic abrasive deburring, and magnetic jet polishing, other things you will study in this particular course. You can see here, this is the north pole and this is the south pole. In between you will form a magnetic brush, where magnetic brush consists of carbonyl iron particles, which are iron particles basically, which in a pure form, at the same time abrasive particles. Whenever you have a electromagnetic field, these particles will form a chain. CIP particles form a chain, that is carbonyl iron particles will form a chain, wherein abrasive particles will held. At the same time, some of the people will also use bonded abrasives, where they will sinter the abrasive particles onto a iron particles. That is what you can see in these particular things. These are all one type of bonded abrasive particles. In this chapter 7, you will study about magnetorheological fluids, where it is a slurry basically. These fluids are used for sophisticated applications like contact lens polishing and other things. Okay. So, magnetorheological abrasive flow finishing process, magnetorheological finishing process, magnetorheological float polishing, and magnetic assistive other processes we will see. Whatever you are seeing here is MRF, that is called magnetorheological finishing process, where you can also see the video how the magnetorheological finishing process works. Whenever magnetic fluid is put onto the disc where the electromagnetic field is there, it forms a chain, and then you can put the component, whatever the in particularly this workpiece, you can press against the fluid. Since it is a fluid, whenever it comes to the exposure or whenever it near to the electromagnetic field, it forms the stiff fluid and the polishing will take place. The stiffness is a function of your composition and the field strength, that is magnetic field strength. At last, and the last chapter, we will study about hybrid abrasive machining processes and finishing processes. One is the chemomechanical MRF we will study. Normally, how the chemical aspects of this particular process also come into picture, and along with the magnetorheological finishing process, finishing of advanced materials like biomaterials, electronic materials, aerospace materials, wherever required. Normally, the complex surfaces of knee implant, which is a biomaterial, you have to finish, and the components like which are used in fighter jets, which are used in the other aerospace applications, component and defense applications, and silicon based electronic things also, components also we will see how to finish, and latest updates if possible time is there, and if what are the latest updates in this particular abrasive machining as well as finishing, and we will summarize this particular course. So, this is about the complete elaborative way how I am going to teach or how the lectures are planned. Okay. Sometimes it may go plus or minus some things, because this is what the exact plan I am structuring for this particular course, and it may slightly vary. In some of the cases it may go for 4 lectures, some of the cases it may go for 2 lectures. Mostly I will try to do my best to give you a better knowledge in a systematic way. Now I am moving to the introduction to the abrasive particles, because this particular course is completely deals with abrasive particles. So, you should know what is an abrasive particle, how you can measure the size, shape and other things. So, various abrasive particles commonly available across the globe and in particularly India. You can go for alumina, silicon carbide, boron carbide and cubic boron nitride particles and diamond particles. Okay. So, hardest particles are diamond particles. The most of the abrasive particles are ceramics. That means that they are brittle in nature. Okay. If you just press it with a mechanical force, it will fracture. Assume that it is like a glass. If some external force is applied, it will fracture into pieces. So, that is called a ceramic particle. So, these particles are brittle in nature. These advanced abrasive finishing processes, if you require to finish in a nano level, normally you will go for a high hardness abrasive particles such as diamond particles and other particles. These particles are called as super abrasive particles. Most of the abrasive particles are stable materials. Normally Al2O3 or SiC, these are all stable. They don't have free electrons in the outer shells in the most cases. So, these are more stable. So, chemically reacting is very less compared to metals. So, normally two abrasive particles are used in most of the machining and finishing applications, that is called alumina or aluminum oxide, and another one is silicon carbide. If you see the difference between these two particles, aluminum oxide or alumina is an inorganic compound which a chemical formula Al2O3, and normally this is called as SiC, silicon carbide. Okay. So, the molar mass is 101.96 gram per mole and another one molar mass is 40.1 gram per molar mass. This is also called as alumina and this also called as carborundum. Silicon carbide is called as carborundum. Alumina is a electrical insulator and it is a semiconductor. Silicon carbide is a semiconductor. Normally, it also very less conductivity will be there. That is why many cases some of the people are trying for electric discharge machining of silicon carbide and other things. And this is the white crystalline powder. Silicon carbide is yellow to green crystals you will get, and the melting point and boiling point of this alumina is 2072 and 2977 respectively. In the melting point of silicon carbide is 2830 centigrades. It don't have the boiling point, it directly sublimates. Abrasive particles, normally the abrasive particles are fabricated by many ways. Some of the common ways are, one of the most common way of fabricating the abrasive particles is by ball milling operation. Whatever you are seeing is a planetary ball milling process, and where you have a balls. These are the balls that are used, and these balls are placed inside these things. You can see here how the balls are placed inside this one, then you put the lid on top of it and you close this one like this. Then these particular things are placed here. So, you can see here in the 4 things are there, just you place it, then you close the lid like this. Now, the machine whenever before going to operation, it looks like this. You can give your input conditions here and you can make the particles. Okay. Assume that I am getting a very coarse particles or big particles. As I said, these are the ceramic particles. Whenever you place this inside, and assume that this is the particles that I want, and I want to convert these particles to these particles. Assume that this one is my particle and I want to convert into 2. I place these particles inside and I will place along with the balls, and I will close the lid, then I place in a ball milling and I will rotate it. So, it will rotate with high speed. These balls are much harder balls. So, this will hit the particles. Since it is a ceramic particles, brittle fracture will take place, and in a go of 5 hours to 8 hours, sometimes people go for milling into 24 hours also. So, you can get fine powders. Okay. So, similarly, if at all I want have the big particles, I want to make it small, you can go for the big commercially used methods. Assume that I want to make a smaller particles, you can go for mass production about this type of things, and where you can see the balls are there and you place the abrasive particles whatever you require, then you will get the particles. Similarly, you can convert big particles like these particles to these particles, or these particles to these particles. You can do particularly by this one. Just what you have to do is you have to place inside this chamber, and once you close it, you rotate at very high speed. Sometimes people also give the vibrations to it, so that you will get much better particles, uniform size and other things. What is the difference between bonded abrasives and unbonded abrasives? If you see here, the abrasive particles are individual entities. This is called unbonded abrasives. As I said in the earlier slides also, these are called bonded abrasives. You can see the periphery of the abrasive particles, it is completely bonded with a bonding material. Shape and size, normally you can see the size from coarse to fine to super fine. Normally abrasive particles are divided into 4 segments: coarse, medium, fine, super fine. Okay. So, if you see here, these are the coarse particles, and whenever it comes to a big size, then it will have the bigger size particles also. Okay. So, the scale is different. People should note what is the scale size here, because the particles are looking approximately same, but the scale size is different. Okay. So, you should be very careful about the scanning electron microscopy scales. Okay. So, how do you calculate abrasive particle size? Normally abrasive particle size, whenever particular person want to purchase a particular size, you always mention the mesh size. Mesh size means number of sieves. Sieves means normally no, our mothers normally sieve the wheat flour and other things. So, you will have a sieve like this. Okay. Okay, this is called a sieve. So, normally this represent in terms of mesh size. So, assume that you are going to measure the mesh size, ordered mesh size 1000. So, how do you calculate? Particle size equivalent to 15.2 mm by the mesh number. Okay. In this particular case, if you convert into microns, it will become 15,200 divided by 1000. So, approximately it will comes around, or exactly you can say, micrometers. The particle size or average diameter of this particular particle is 15.2. This is the how you measure or how do you calculate particularly the size of an abrasive particle. Okay. Once you know the abrasive particles, you have the tables when you call it as a coarse particle, when you call it as a fine particle, when you call it as a super fine particle, and other things you can understand. If the particle size is very small, then you can call it as a super fine particles. Okay. There are varieties of abrasive particles, and some of the applications require coated abrasive particles. Okay. So, people also uses the coated abrasive particles. Now, normally you can see the abrasive additive coating is there, at the same time size coating is there, abrasive grain particle, you can see this is abrasive grain, and the base coating is done, and backing material. Normally, whenever if at all I want to make a super abrasive particles, you can go for coating very hard materials on abrasive particles. Sometimes people want to make soft coatings also on abrasive. Okay. If at all people want to go for soft coating or hard coating, you can go and coat these particular things. Some of the people also uses functionalizers. Whenever you are going to talk about the magnetorheological finishing process or polymer rheological abrasive finishing processes, these are the abrasive finishing processes. These particular processes, if at all you need perfect bonding between the rheological additives at the same time with the abrasive particles, that bonding strength you can vary by functionalizers. So, you can coat, or you can in a ball milling operation, you just put the functionalizer and you can mix it, or ultrasonication, or you can use many techniques to make it functionalize, or you can coat it. These are called as a coated abrasive particles. Particularly summary of this particular course, I have acknowledged to the many of the people from the CET head Professor Kejwania to Professor Narayan Reddy, who helped me technically, and Professor Kejwania helps in terms of providing the facilities and providing the staff. I am thankful to him. And Professor Narayan Reddy, who is very good friend of me, and he is no more. He gave me a lot of knowledge from the technical point of view. He always thankful for Professor Narayan Reddy. And course, who study and why you have to study, to whom it will be helpful, I have already explained. And the reference materials, I am again telling you, this particular course not only depend on the books or the reference books or the reference materials, I am also following some of the latest research papers. So clearly, if you can understand, you can easily answer the assignments as well as you can easily answer the examinations. Okay. To understand the questions, to understand the assignments, you please understand the course and strictly follow the course so that you can easily gain the knowledge as well as the marks. Introduction to manufacturing, overview of the syllabus in a nutshell as well as elaborative way, how and what I am going to teach, and introduction to abrasive particles, manufacturing of abrasive particles, how the abrasive particles are fabricated. These are the materials that we are going to use in the grinding process, lapping process, super finishing, abrasive flow finishing, magnetological finishing. Anywhere my abrasive particle is a main particle or the main element of this particular course. So I have explained you about the abrasive particles and size and shape. The size and shape, size is random, normally you can see it, but the shape, normally the cutting edges are randomly oriented and the shape is also random. A abrasive particle may be like this, another abrasive particles may be like this, another abrasive particles may be like this. So the shape is random, and the same time you can see the cutting edges, this particular cutting edge, this particular cutting edge and this particular cutting edges are also random. So if randomness increases, the surface roughness will give better and better. That means that surface roughness value will be low and low. Okay. And at the last, I am summarizing this particular class. Thank you for your kind attention in this particular class, and in an elaborative way about this particular course and content, we will come up and hope you gain a great knowledge from this course. Thank you.